Okay, just for your info, this week you will be offered 2 homework. The second homework says advanced. Advanced because it's related to applications of linear equations, just like the problems we're going to face today. The other homework is just an ordinary homework related to quadratics. Okay, 2 situations that you could be facing in the homework that says advanced. The first of the situations is related to applications of linear equations that has to do with the real roots or the roots that belong to the world of the real numbers. So let us do some examples. So the name of the session today is applications of real equations, of quadratic equations, or which is the same word problems. Word problems, okay? Is the same. Applying something to a real life situation. Okay, so problem number 1 then will be related to the following. It says, the area, you don't see what I'm writing, and that's interesting. It has some lags. Okay. The area of a rectangle is 27 meters to the second power. And the length of the rectangle is 3 meters less than twice the width. Find the dimensions of the rectangle. Okay. Okay, so here we go. The area of a rectangle is 27 meters to the second power, and the length of the rectangle is 3 meters less than twice the width. Find the dimensions of the rectangle. Well, as all word problems that have to do with figures, well, writing the figure could help. So making the drawing of the rectangle could help us. So here we go. Let us do the rectangle. Okay, and let us imagine that this is the length and this is the width, because that is what we all know about rectangles since forever. Then they mention that the area is equal to 27 meters to the second power. And then, according to the information provided by the problem, it says the length of the rectangle is 3 meters less than twice the width. So we can say that we have the width and the length happens to be, if we want to show this in terms of width, the length happens to be 3 meters less than twice the width. Do you all agree with me until this point? The length in terms of width is 2 times the width minus 3, because it says that the length of the rectangle is 3 meters less than twice the width. Okay, and the creation of equations out of information is something that you and I already practiced, remember? So we can establish then an equation here. Here we go. Look, this is lagging, so I'm going to stop sharing so I can share again. Let's see if it gets better. There. Okay, so the area of a rectangle, yeah, it's better now, equals base times height, right? That is a formula since forever. Or, which is the same, you can also say that the area of a rectangle is going to be equal to length times width, all right? Well, in this problem, we can create an equation. If we use the information provided by the problem, this is what we get. We know that 27 meters to the second power is going to be equal to the multiplication of width times length. So is the W of the width times the length, which is 2W minus 3. So from there is how we create an equation. We have that the area equals base times height, or area equals length times width. So this is the moment to use distributive property to create an equation. So we're going to then have the following. 27 is going to be equal to W times 2W, 2W to the second power. W minus 3 minus 3W. And then, as everybody knows, we have to make our quadratic equal to 0 so we can start thinking about how to solve that one. So this 27 is going to be sent to the other side, and we're going to be having 2W to the second minus 3W minus 27 equals 0. So this is the quadratic I'm going to be working with. And I created that quadratic out of the reality of width times length equals the area. Okay, how do you want to solve that quadratic? We need to find the roots. What do you think is a good method for that one?
Factoring.
Okay, factoring, that could help. Let's see if it works. Factoring. How will you factor that one?
2x minus 9 and x plus 3.
Okay, actually it's W, but it's the same. We can say 2W minus 9 and W plus 3. Or if you want to think about the W in terms of X, it's exactly the same. That's the root we are looking for. So yay, when we do that, this is the solution of quadratics by factoring. So this one is going to be made equal to 0, and this one is going to be made equal to 0. So 2w to the second power, I'm sorry, 2w here. 2w minus 9 equals 0, and here w plus 3 equals 0. So 2w equals 9, w equals 9 divided by 2, w equals 4.5. And here, w equals negative 3. So this is a very interesting moment, an important moment to think. We are looking for the solutions of the quadratic, and yes, the solutions of the quadratic are both this one and this one. They are both solutions, but if we are thinking about something that is related to areas, do you think that we can go and pick both of my values?
No.
No, exactly. So this is what happens. This value is for academic purposes only. This one doesn't help me in real life for this problem because I'm talking about an area. So when talking about areas, negative values make no sense. I'm talking about the dimension of a figure. So this value is not going to be used. I will only use this value. So for academic purposes, both are the roots of my quadratic. But for real life purposes, only one of them helps. So the question was to find the dimensions. Okay, so I have to go back to my problem and insert my values. I already know that the width is going to be equal to 4.5 and the length is going to be equal to 2 times 4.5 minus 3. So my length is going to be equal to 4.5 times 2. Sorry, my calculator froze. And my mind kind of froze too. Okay, 4.5 times 2 minus 3, so it's 6. So the answers for this problem will be that it has a width of 4.5 and a length of 6. And if you want to check if what you got is right, you're going to get 6 times 4.5, which is 27. So yay, the answer is correct. So that the quadratic equations, when having applications related to geometry or measurements, in many times forces us to get rid of the negative answer and focus on the positive answer only. It happens a lot, more often of what we want to believe. Okay? We have time for other one. Can I move my screen so we can create another one?
Yes.
Okay. Thank you. So here we go. I'm gonna move the screen and have problem number 2 related to more or less the same. So it says, the length of a rectangle
Teacher,
Yes,
can I go to the bathroom?
of course, honey.
Okay.
Again, it's a rectangle. It doesn't have to be a rectangle all the time. It could be a triangle, or it could be, well, most of all, it goes for triangles and rectangles. And the only thing you do is to recreate the formula of the figure and just solve it. So this is the information. Okay, so here it is. This is the rectangle. So here, here. So the length goes here, the width goes here. And it says again that the length of a rectangle is 7 more than twice the width. So the length is going to be equal to 2 times the width plus 7. And all that has an area of 99. So yay, my equation is again 99 is going to be equal to the width that multiplies the length in terms of width, which is 2w plus 7. And now it's just about me multiplying with distributive property. 99 will be equal to 2w to the second plus 7w, and there is the moment in which your quadratic is born. So 0, because I make it equal to 0 by passing the 99 to the other side. 0 is going to be equal to 2w plus 7w minus 99. So that's my quadratic, and that is me using whichever method of solution of quadratics. If I want to use the one of general formula, works anyway, or if it's able to be factored, lucky me. In this case, apparently, it seems to be factorable. So let's see if it's true. Well, yeah, apparently I can factor this one, but you know that it doesn't have to be like that all the time. I make both terms be equal to 0. And again, I have one value that is going to be discarded because it doesn't help. The negative value makes no sense for this type of application because I'm talking about geometry. So this value not helping, this value totally helping. I go back and I discover that the width is 5.5 and that the length is equal to 2 times 5.5 plus 7. So the length equals to 5.5 times 2 plus 7, 18. And yay, it is 99. So the answers is the dimensions, because that was the question since the beginning. This is the answer. So again, what to know about applications of quadratics? Well, that sometimes, even though both answers make the roots, one of the answers doesn't make sense in the real life, so I need to discard it and forget about it. I just focus on the one that belongs to the real world numbers. When I say real, I talk about positives. Most of the times in applications in real life of these problems, the negative value disappears. Most of the times. That's what it is about. It's very rare that one of the applications could have a negative answer, but it could happen. So it's just about you using your common sense.